All right, Gators, we're still on page 187. We're continuing with lesson 4.1, laws of exponents, and we've done a little bit of work on expanding our exponential expressions. Okay, those are expressions where we have something that's raised to a power using an exponent, and it's repeated multiplication. Okay, but what we're looking for some patterns, some rules to see if we can do some shortcuts here, and that's where the product rule and the power rule are going to come into play. All right, so I'm going to skip over A because some of you were assigned that for homework or an assignment. Let's go ahead and jump to B right here. And in B, I have x squared times x to the third. So again, repeated multiplication. It's asking us right here, start by expanding the expression and then to simplify. So I'm going to go ahead and expand it. X squared is x times x. And then x cubed, x to the third power would be x times x times x, that repeated addition. Now what you're probably noticing is that if we do simplify this, x to the fifth, right here, 2 plus 3, well, that equals 5. So if I added the exponents, it's a faster way to do it. So maybe I didn't have to do all this expansion here. Let's take a look at this one right down here. Okay, so expanded notation. I have x to the fourth, that's 4 x's. I have x to the fifth, that's 5 more. I have x to the third, that's 3 more. That's a lot of x's. In fact, I probably can't even fit it all the way across the space that I have here. And so looking back at this, 2 plus 3 equals 5, it worked. What about 4 plus 5 plus 3? 4 plus 5 plus 3. 4 plus 5 is 9, plus 3 is 12. X 4 times, x 5 times, x 3 times. We're going to simplify this to x to the 12th. Okay, so that's what we're looking at, is we're starting to see this pattern here where I can just add my exponents, and that is what we're going to call the product rule. Is that for both of these right here, that I can just go ahead and add the exponents. Now let's take a look at this one right here. The difference here is that we actually have parentheses. So it's grouping it, that's a grouping. Now remember, order of operations, that PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Here we do have parentheses, so we have to address that first, and the exponent actually applies to only what's inside of the parentheses if it's sitting there. So in this case, we're going to expand k to the 3 times k to the 3 times k to the 3. Okay, we raised it to the third power, so we had to multiply it 3 times. Now let's go ahead and apply the product rule. 3 plus 3 plus 3, k to the 9th power. That would be simplified. So looking at this with the parentheses, I see a 3 here and a 3 here. I don't want to add them because it's not k to the 6th. When we expanded it, k to the third times k to the third times k to the third, we see something a little bit different here. Let's hold off on trying to develop a rule, but you guys probably see it already. Let's do it with this one right here. X squared is in parentheses, it's raised to the 4th power. Okay, it's expanded multiplication. That's the whole concept here, is we're going to do x squared times x squared times x squared times x squared. Raised to the 4th power. But you can see we're kind of running out of room, so hopefully we're going to come up with a rule that simplifies that so that we can make it a little bit easier. We're going to use our product rule. We're just adding the exponents because we're multiplying. If we're multiplying, they have the same base. They all have an x base, and then we're going to add their exponents right here. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Simplified is x to the 8th. So what you probably noticed here is that 2 plus 4 would be 6, but 2 times 4 does equal 8. And up here, 3 plus 3 would give us 6, and we knew that didn't work. But 3 times 3 equals 9. This right here is going to be called the power rule. And basically it's saying is that anytime that we have an exponential expression or any type of expression raised to a power, that the exponents inside those parentheses, we can multiply them by the exponent outside the parentheses and come up with a simplified version of that exponential expression.